Assalamualaikum and good day. In this video, we will covering the last part of our heat treatment of ferrous metal, which is on tempering. It is a process of heating a martensite at a temperature below eutectoid temperature to make it softer and more ductile. Please remember, it is process of heating martensite at temperature below eutectic temperature, which is below 727 degrees Celsius, to make it softer and more ductile. As we know, martensite has the properties of hard and brittle, so we want to make it softer and more ductile. It is used to reduce brittleness of martensite. The microstructure that will be produced is tempered martensite. The purpose of tempering are to increase ductility and toughness of martensite, to relieve the internal stress caused by quenching. The procedure: immediately after quenching, sample is heated up, normally below eutectoid temperature or A1 line, at about 250 degrees Celsius to 650 degrees Celsius. Then we held it at that temperature for about 2 hours. Lastly, we remove from the bath and cool it in air. Please remember, we cool it in air. You can see in this figure, after quenching process, where we heat up our material above eutectoid temperature, we quench it down and then it will form martensite. After that, we heat it up again until around 250 degrees Celsius to 650 degrees Celsius, and we let it be at that temperature around 2 hours, and then we cool it down in air. So it is slow cooling process. This slide is showing us the temperature for normalizing, annealing or hardening, spherodizing, and tempering. For A is for normalizing, for B is for annealing or hardening, for C is spherodizing, and D tempering. So for tempering process, the microstructure produced is tempered martensite. It is hard but more malleable and ductile compared to martensite. This microstructure consists of extremely small and uniformly dispersed cementite particles embedded with a matrix of ferrite. You can pause this video and look at the figure showing here. Steel will oxidize as it is reheated and begin to show colors. The higher the temperature, the thicker the oxide layer and the darker the color. These temper colors sometimes used as a guide to certain temperature. Please pause this video and take a look for a while on the color difference, and then look at the uses of certain temperature on tempering. Tempering will produce extremely small iron carbide particle surrounded by alpha ferrite. It is decreased tensile strength and yield strength, but increased ductility of martensite. Please pause this video and read the summary of processing option from austenite cooling. That's all on the last part of heat treatment process, which is on tempering. Till we meet again in the next video. Thank you. Have a nice day.